This week, while everyone was looking at Pluto pics, an asteroid flew by the Earth that was worth $5.4 trillion. Why aren't we up there? Think of the dollars. Hey there, everybody. Thanks for watching D-News Today. I'm Trace. Asteroids fly by the Earth all the time. And even though the $5.4 trillion 2011 UW-158 seems like a missed opportunity, back in 2013, asteroid 2012 DA-14 flew by and it was worth some $20 trillion. And in case you're curious, and you're a D-News watcher, so I know you are, some asteroids are simply worth a lot of money, and it's just floating out there, ready for the taking. Asteroids range in sizes, compositions, and shapes. Some are bundles of rubble held together by their own gravity. Others are solid, pockmarked survivors from the early solar system. Looking at UW-158, they found a fast-spinning asteroid, meaning that it wasn't a collection of rubble because it wouldn't sustain such a spin, and it looked sort of like the inside of a walnut. But after looking at the spin, astronomers wanted to know what that old gal was made of, which is kind of an imprecise science, or at least a fun debate. Once asteroids are located, scientists use ground-based infrared telescopes and spectrometers to see which minerals exist in its structure. Different minerals absorb light at different wavelengths. Once they bounce the light off the asteroid, they compare it to charts that we have here on Earth, and they bounce radar off of it even to determine what composition it is by what's reflected back. And it's never made of just one thing. It's moving constantly, so there's usually a scientific debate as to the different minerals present in pretty much any asteroid. Once the composition is more or less determined, asteroids are assigned a spectral classification separate from their letter names. For example, S-type means that that asteroid was found in the inner area of the asteroid belt, closer to Mars, and are mainly stony. C-type asteroids are from the outer main belt and are more carbonaceous, or contain a lot of carbon. 80% of asteroids are C-type. But they also have A, B, C, D, E, F, G, M, P, Q, R, S, T, and V. Gets kind of confusing. Of course, all this can be checked by sending a spacecraft to rendezvous with one of these minor planets, like NASA did with the NEAR spacecraft in 2001, but that is so expensive, so it's been tough to justify. Pointing these tools at UW-158 tells us that it might have a core of platinum, maybe as much as 90 million tons of it, thus the high price tag. But getting there, mining it, and bringing it back is also expensive. UW-158 was added to NASA's Near-Earth Object Human Spaceflight Accessible Target Study, or NASA's NEO-NHATS. These are asteroids that we recognize might be candidates for future manned asteroid missions. Billionaires with space on the brain, like Google's Larry Page and Eric Schmidt, as well as Virgin's Richard Branson, all want to mine these things. The problem is sending the materials to mine an asteroid into high Earth orbit costs about $10 million per ton. And the tech is relatively untested. I say relatively because last week, Planetary Resources Arkyd 3 Reflight spacecraft was launched from the International Space Station. The A3R is the first proof-of-concept test vehicle for landing and extracting resources from an asteroid. We're on our way, chaps. When the A6 goes up later this year, it'll have tools to spot water and infrared to seek minerals on asteroids, which of course you all know about now. These are just the first steps into a wider space economy that would make this whole thing worth it. What do you think about asteroid mining, though? Should we keep our greedy fingers here on the ground or get up there before somebody else does? Let us know down in the comments. Make sure you subscribe for more D-News. And while you're clicking around, I've got a new show. We called it Test Tube Plus because we talk about science and then some. It's 5 episodes in a row on a single topic, and last week was one of my favorite series so far. We talked about science. Where did it come from? Is it in a fight with religion? The ancient Greeks were some of the first people to look at science and religion and kind of equate the two. Start to think about religion in a more scientific way. Come find us over on Twitter and follow us there. We're at DNews. You can also find us on Facebook. Get more videos and more posts all throughout the day. We're Discovery News on Facebook. Thanks for watching.